This video is a reflection of the course EGEE 497, Sustainable Energy in New Zealand, with methods of energy recovery and conversion through conventional fossil fuel methods as well as renewable methods. At the beginning of this course, we spoke about the energy-environment-economy nexus, which seems to be a puzzle piece to understanding how we as humans consume energy with regard to the environment around us. This nexus models the symbiotic relation between water and energy, since water requires energy to pump, cycle through, and treat, while at the same time, energy requires water for running heat exchangers and even irrigation for biofuel crops. So ultimately, it is crucial for any country to align the economics with the balancing of this nexus. This is especially since water and food are the basic requirements for all life. As Hans Rosling explains in his plotting of 100,020 numbers and 200 countries, he outlines how the Western world and developing countries have changed over time and where the world stands with life expectancy and per capita income. This will be another great, important key to understanding how we can use our data to make a link with the water-energy nexus. When looking at individual countries, Rosling explains that the spread of wealth can be quite different for places like China with large populations. So allowing for the influence that accounts for how much energy is being consumed per person will be crucial to understanding where to extract more resources and how to transport them to places that need them most. In the end, we as humans will have to be very conscious of how much we consume, which requires everyone to take action in their lives, especially those with great power in the government and media. With insight from the quest, it seemed that a lot of what was happening with energy in the past has to do with knowing the resources we have in the present and continuing to build off of what already exists. Humans really don't know what our Earth is capable of until we have a deeper understanding of it. We have to continue to find new ways of approaching energy, and we have to utilize the technology we have in ways that keeps us in check with the Earth and its inhabitants. That is our contribution to the Earth. To use what we have, balancing these resources not only as a society, but as individuals, because at the end of the day, we have to know that whatever we use is being used with proper intention and for the greater good of those around us. We are integrated with those around us at any point in our lives, and so if we can understand how to put those around us before ourselves, the world's energy requirement per capita could easily reach stability. Solving the energy problem will require humans to work together with an approach that makes Earth and its inhabitants the true concern. We'll always be in search for more energy, more food, more water, and more time. But what this really comes down to is treating those around us with the same respect as ourselves, in order that we can provide to others what we hope for ourselves. Our own lives carry a lot of perspective. Where we come from and what we do is important, but who we spend our time with and how we communicate is of utmost importance. It starts with really understanding each other and where we come from so that we can have shared perspectives of our shared environment. Before traveling to New Zealand, it was insightful to have a better understanding of the people in New Zealand and how they care for their own environment. Since the island of New Zealand is self-contained, they have to know that whoever is traveling to their country will be good stewards to the land and treat it with as much respect as they do themselves. Arriving in Queenstown, I began to think about the atmosphere and the environment that is present there. Queenstown seems to be heavily populated with tourism, since much of the attractions were adventuring and sightseeing. Tying this to energy would mean that the more tourists travel to New Zealand, the more they need to expand with their architecture. This was prevalent in the city with construction as well as new apartment complexes that seem to have been constructed recently. New Zealand has tapped their energy quite well. However, they need to be sure that their social ties with energy remain stable, since transporting power from one island to the other may cause more tension in the future. Now we can switch gears to the touring of the North Island. Our first day began at Huntly Power Station, where the plant was commissioned in 1983. The station produces almost 5,000 gigawatt hours per year, which is 17% of the country's energy requirement. However, the plant can produce up to 30% of New Zealand's demand, and they plan to phase out coal by 2030. The power station has 4 250 megawatt units, which can burn either natural gas or coal. the coal of which is less likely to be utilized through Rotowara Mine, since there are plans of discontinuing the mining for the future. The power station has also developed a series of concrete slabs to prevent backflow of water into their channel for water cooling. That Tuesday morning, we set out for Bridal Veil Falls, where we got a stunning look at the 180-foot waterfall located on the Pacocco River. The falls were a great sight, and walking through the trees and vegetation was also half the experience as the subtropical climate presented itself. Jumping back into the van, we made our way to Teuku Wind Farms, where we got to witness the beauty of windmills located outside Raglan through a collection of 28 wind turbines that have a capacity of 64 megawatts. The project was completed in March of 2011 at a cost of $200 million. Leaving the farm, we made our way to Taupo and stopped by the Waikato River and Arapuni Dam. The Waikato River supplies power to 8 dams and 9 hydroelectric power stations, which were constructed between 1929 and 1971. Traveling to Arapuni Dam, we walked across the suspension bridge and eventually made our way down to the power station. The Arapuni Power Station was built in 1929 and is the largest hydroelectric power station on the Waikato River. The next day, we traveled to GNS Science, which does investigation into many of the Earth's geological aspects, including the Earth's geothermal, plate tectonics, rocks, minerals, natural disaster monitoring, and even the Earth's magnetic field. This was quite the interesting lab operation, since they were able to work on research that could save a lot of money for industries that deal with drilling, since knowing what is below the Earth's surface and the potential for disruption is important to the geothermal energy facilities. The touring of this facility really opened up the potential for understanding how geothermal goes beyond just the piping, and helps us understand the depth at which professionals communicate knowledge in the relevant fields. So moving forward, we traveled to Mercury Energy's geothermal station, Rotokawa 2, which is the second largest station in New Zealand for geothermal. Justin gave a discussion about the possibility of land subsidence, where large amounts of fluids are removed from the surface, causing the land to fall inward, similar to sinkholes. However, the problem is resolved by pumping geothermal fluids back into the reservoirs. Along the tour, we walked along the pipes that transport fluid through various chambers and cooling towers. Walking through, we could smell hydrogen sulfide in the air, which is an issue that must be kept at bay, since the gas will convert to sulfur dioxide, damaging surrounding crops and forests. Scrubbers can solve this issue, given the proper funds and avenues to transport the byproducts. On Friday, we ended the touring with a trip to the Methanex plant and the visitors center that presented a large-scale model of the facility that produces methanol. The model explained the various processes that natural gas must go through, such as reforming and distilling, to get the clear liquid methanol that can be used as an alternative fuel source, which is soluble and biodegradable. Finally, as we ended the trip in Auckland, it was neat to travel the city and experience the various cultures that are intertwined there. Auckland has a population of around 1.7 million, and the majority of the population is Polynesian. The city itself is surrounded by fertile land and a network of waterways. It is classified as one of the major global cities based on the waterway network there, allowing for a great amount of trade. The city's terrain is also quite hilly, with many steep roads compared to cities like Philly or New York. So in conclusion, the trip to New Zealand was heavily insightful to understand how a culture of people have worked to integrate renewable energy from a variety of resources, including oil, wind, hydroelectric, and geothermal, while also using its geographical science to better control its impacts on the land itself. Thank you for watching, and I hope you've enjoyed.